My name is Billy Hoffman. I'm the lead R&D engineer at Spy Dynamics. I work for Spy Labs. Today we're going to be talking about security issues with Ajax. There's a lot of them. You know, Web 2.0 is very popular. Everyone's like Ajax, buzzword, e-commerce, it's all this fun stuff. We're going to actually talk about what the security of all this is. You know, I love my responsive Google Maps as much as the next guy, but let's see what the security issues are involved with deploying Ajax-enabled applications. Let's see what we can do to try to fix them and what we can do to try to mitigate these risks in the future. So we're going to run through real quick the architecture of traditional web application. Touch briefly just on what is Ajax and why does it help? Why is there a need for technology like this, or a suite of technologies really? We're going to talk about 4 huge security issues with Ajax and just Ajax applications in general. This is mainly just all the nasty stuff you can do with cross-site scripting. And finally, guidelines for writing really, really secure Ajax apps. I'm also giving a talk at 4:45 called Web Application Worms and Viruses. We're going to talk briefly here about like the MySpace worm and the Yammer worm that hit Yahoo, because those were notable examples of Ajax worms. We're going to go into much greater detail this afternoon, so I encourage you, if you like what you see here, to come on back. Okay, so architecture of web applications. So yeah, these things are pretty basic. Essentially, the browser receives some type of input from the user. You know, I click on a link. Let's say I'm filling out a form. We have this JavaScript logic layer in there. It performs simple logic validation, input validation. The whole reason this thing originally existed is to try to make web pages more dynamic, and also crossing that internet cloud is expensive. You know, on the order of, depending on your bandwidth and your connection speed, you're talking half a second to 2 or 3 seconds, depending on how much data is coming back. On the server side, you've got some type of back-end business logic. You've got some ASP or some PHP, some JSP, something like that, which actually takes the input you submitted and says, oh, okay, they're signing up for an email letter. Let me get the username, or let me get the email address they gave me. Let me get the, their interests, all of those things, insert them into some back-end process. Like I said, talks to possibly some other types of tier, in this case a database. They're normally back-end processes filling this database. So a great example is Google. I mean, obviously when you do a Google search, it doesn't spawn a crawler to go find this stuff. They've got crawlers constantly running, inserting into that database, and so we're going to hit that tier. And finally, the resource is ultimately returned to the user in the form of a web page, a Flash object, a Flickr set. I tend to talk kind of fast, so I'm going to try to slow it down. But if you have questions, please raise your hand and just ask, because I would much rather address questions now than to find out you didn't understand something early on. So, problems with traditional apps, and I totally stole this from Adaptive Path. But classic web applications, we talked about that big internet cloud. It's expensive to go across that. It takes time. And unfortunately, a lot of these times are fixed. I mean, your bandwidth's fixed. The network latency is fixed. The size of the response is fixed. And so normally a user will interact with the device, interact with the web page, submit a form, and then you've got this big, long wait period where it sends, the server processes, finally gets it back. This is why, in the late 90s, web applications sucked, because they were very unresponsive. You'd click something and kind of get something back later, very unresponsive, completely unlike desktop applications. The prime example is MapQuest. Now, I'm not saying MapQuest sucks now. I kind of like them. But who here used MapQuest in like 98, 99, 2000? Yeah, you didn't really want to use it, did you? It was horrible, because you'd click a link saying, hey, I need to navigate a little to the left or a little to the right, and you'd have to click this little east-west border thing, and the whole image would jump over that far. It was not granular at all. On top of that, when you click this button, the entire page would have to refresh. It would go get the little paragraph at the top. It would go get the ads on the side. I mean, it would do a complete HTTP request across the internet cloud and pull the entire new page down. And the only thing that really changed is I wanted to move the image where I currently was. You did zoom. It would take 1.5 seconds. So it was very stop and go. It's like city driving when you have a Porsche. It just upsets you, and you want to fix it. So the whole thing is we want to try to reduce this long wait, because these long pauses are very noticeable. I mean, think about Word, right? If Word waited a second every time you pressed a letter or every time you ran spell check, it would drive you crazy. Now, unless you happen to be running like a 2 gig of RAM machine, Word probably does this for you. And I can't do anything about that. But in terms of web applications, we needed some mechanism of making them respond the way a traditional web application or a traditional desktop application would. And that key really revolves around reducing this long wait, because you need the application to be more responsive, more interactive. But of course, we're kind of crippled right out the gate. I mean, the request we make, hey MapQuest, hey Google Maps, zoom in, or go, 5 degrees to the right or to the left. I mean, that's a fixed. It's an HTTP GET. It's got some headers and some cookies. I mean, that's a fixed size. The response it's going to push back to me in the terms of an image or a full HTML page, that's also fixed. The network and latency is fixed. How do we actually make, if it actually takes as long as we saw right here, if it actually takes this long to go there, propagate, and come back, how do we trick the user into making it seem more responsive? Well, this is exactly what Ajax does. And the way it does it, well, so what's Ajax? Ajax is really just an acronym for Asynchronous JavaScript and XML. It's a suite of technologies. The quick and easy definition of this is it's a way to extend JavaScript so that it can make HTTP transactions without the user having to do something. So in this case, we see the traditional web application. The only thing about the architecture has changed is right there in the logic layer. Now JavaScript can contact the server. It can make requests on your behalf. So what we can do is intercept a user's event. I click a button, I start typing in a text field. JavaScript can then send that HTTP request and give immediate feedback to the user. The application's still responsive. You can still click on links, navigate around, because this transaction's occurring in the background. It's not doing what we call a hard refresh. Eventually, the process on the server returns, and we present the page to the user. Again, stealing from adaptive path. Immediately after we give it input, we can get responses in the display over here. Meanwhile, the HTTP request still propagates there and comes back. We haven't reduced this cycle at all. It still takes this long, this big U shape here. That's still there. But by having this JavaScript that's being able to continue to operate on user events and operate, we think it looks good. The classic example of this is really Google Maps. Google Maps, the first time you used it, I'm sure you're like, my God, this is better than MapQuest. Because it was. You wanted to go to the right a little bit, you just clicked and dragged, and you were there immediately. What's happening with Google Maps is it's using Ajax, to make these HTTP requests in the background. So as soon as you start looking at, say, Atlanta, which is where I'm from, you zoom in, and already JavaScript is starting to fetch all of the images around where you're currently looking. It's also starting to fetch everything that's one zoom level down or one zoom level up. That way, if you click or move, it's already got that data cached. If you've got a slow connection or you've got a really, really fast hand, you can actually drag off the end of the world in Google Maps. Just click and start dragging like mad, and eventually you'll start hitting gray because you're moving faster than it's actually pulling down images for. So needless to say, the application is a lot more responsive. We find this enjoyable. Writely. Has everybody here ever heard of Writely.com? See a couple nodding heads. So Writely is a word processor written in Ajax, and it's actually really impressive. So especially when you look at it and you're seeing that the feedback and the response is similar to Word, and then you realize that it's actually doing spell checking, it's doing all of these kind of classic web app or classic word processor functions, and it's over the web, you're amazed. And it's all because of Ajax. So the crux of Ajax is this fun little thing called the XML HTTP request object. Essentially, you can send any HTTP method you'd like. I've got a little piece of JavaScript over here. Basically, you instantiate the object. You tell it, you give it a callback function. You say, hey, when you're done with this request, call process request change. And then you say, hey, do a GET request to some URL. And true is, it has to do with blocking versus non-blocking. When the response is done, we come back and we say, all right, if the request completed and the response code was 200, great. So this is how JavaScript can then, and it can actually go, in this example, req.body. It can start actually accessing the contents of the response. Jeremiah just gave a really good talk about port scanning with JavaScript. I'm going to talk a little about port scanning with JavaScript too. The trick is that we don't use Ajax for it, which is kind of bad. It's good because we get around the security, some of the inherent security in Ajax, but it also means we can't look at the response. And obviously Google Maps would be kind of useless, or Writely would be useless, if it can make a request but actually can't look at what it gets back from the server. Now, this is one of the interesting limitations of JavaScript that they put in for security purposes and then promptly wrote a hole to get around this. And JavaScript, or Ajax is only allowed to contact the site it came from. So if you're looking at maps.google.com, and there's some JavaScript that gets pulled down, that makes Ajax requests back to maps.google.com. If I said get URL is yahoo.com, JavaScript would actually fail on the client side. It won't let you make those requests to other domains. It won't even let you make a request to www.google.com. It also won't let you make a request to maps.google.com, port 443 or any other port. You actually have to go back to the host and port. And finally, HTTP, the requester object, can fetch everything. I can grab XML. Don't let the name fool you. I can grab things other than XML. I can grab HTML. I can grab raw text. I could grab, in the Microsoft Atlas framework, which is their Ajax framework, they are actually pulling down new JavaScript, which they then proceed to execute. I can grab images, Flash, multimedia, and like I said, script. So what are these problems? So we've talked about JavaScript, but what are actually the issues here? Well, Ajax applications have a huge attack surface. They have a much larger attack surface than traditional applications, and we'll get into why that is. And when I talk about attack surface, I mean the inputs you have into the application. Consider CNN, for example. CNN's a really large site, on the order of a couple million of pages. But how many inputs does it have? Well, you've got a place where I can search news stories. You've got a place where I can insert a stock symbol to get information. You've got places where I can say, sign me up for these email alerts. So you can actually submit, here's some email keywords I'm interested in. Or you can actually say, all right, let me sign up. But really, if you look at all of CNN, it's only got about a dozen or so places that the user can actually give CNN input. That's the attack surface. I can try to SQL inject you through that, cross-site script, parameter manipulation, file disclosure. Those are really the crevices, little holes that an attacker will try to get into your application. To relate it to a house, these are your doors and windows. These are where I try to break into your house to steal your stuff. And so you need to lock those down, obviously. There are several implementation issues with Ajax itself. Oh, I'm sorry. Yes, we're going to talk about that. That's what's known as a bridge. Yeah, we'll talk about that. And I'll tell you, it's actually kind of funny that it was a good restriction to have. And I also understand why it would make sense to have Ajax talk to other domains. And so they came up with this concept of bridging. And bridging is actually a very large problem, as I talk right here. The way they implemented doing bridging was tricky. Basically, what happens if I'm running, BillysBookstore.com, and I want my users to be able to access the Amazon.com web API so they can do author search or something. And I want to use Ajax to contact that. Well, we already said that Ajax, if it came from BillysBooks.com, can't talk to Amazon.com. So there's something that's called an Ajax bridge, which is basically a web service running on BillysBooks.com, which forwards all of my traffic to Amazon.com. It's an open proxy and has all of the problems that an open proxy has. There's also a lot of buzz around Ajax. This almost sounds kind of like a lame security issue, but seriously, the hype and the buzz around Ajax is causing immense security implications, just in terms of what it's doing to the knowledge base, the types of resources that you can get out there to learn about Ajax. They're really quite poor. So, the attack surface of an Ajax application. We started talking about this. In a traditional application, everything really existed on the server, with the exception of maybe some client-side validation that I was doing. Let's make sure that they didn't enter a bunch of letters for the zip code. All the application took place on the server side. And it's very funny how everything old is new again. We went from timeshare computers to personal computers, and now we use our personal computers basically as dumb terminals to talk back to a centralized server again, which has all your applications. So you guys are all familiar with this. And what you're actually doing is you're really sending commands to the website. You're telling it things like, hey, the user clicked the checkout button, or I'd like to submit this title and this body to a forum, or please give me all the information about product ID 24. You don't know how the web server services this request. You don't know when I say, hey, submit this post to a forum. You don't know what database it's contacting in the back end. You don't know what it's doing to the different inputs you gave it. You're really just giving it a big block of text and say, handle this. And that's really key. It's what the web service should do, but you don't tell it how to do it. So how do we attack traditional web applications? Because we're doing it right now. Well, really, the attacks involve sending malformed commands. So we'll submit a post with script tags in it, trying to do a cross-site scripting attack. We'll upload a really bad GIF image or a ping image as our avatar for a forum trying to corrupt their backend systems. We'll tell the web app, hey, give me product ID -1. So what we're really trying to do with attacking web applications in this traditional manner is you're trying to hit these edge cases. You're trying to say, I bet the programmer never anticipated it. Excuse me. I was up pretty late last night, so I apologize if my voice is a little scratchy. What you're really trying to do is hit these edge cases that the programmer probably didn't take into account. Maybe the programmer never anticipated a negative product ID. Maybe the web programmer never anticipated having HTML inside a forum post. And this is the interesting thing, because input validation in web applications is how you actually stop these types of attacks. You want to ensure the commands I'm getting from the user are correct. If they tell me, view shopping cart and give a session ID, that session ID better be valid and should be the session ID that I actually issued to that person, so they're not trying to steal somebody else's shopping cart. The input validation really takes place on both the client and the server. Like we showed back here, the attacker can talk directly to the server. I don't have to go through this JavaScript layer. You can browse the internet using Telnet. I mean, you really can. So you can't assume when you're doing input validation that any of the input you're getting from the user has passed through any type of validation. Client-side validation exists solely for performance, because crossing that big internet cloud is expensive. So on the server side, we actually validate, hey, was this negative? Hey, was this actually a zip code? Now, you'd think this would be easy, right? Because I wrote the application. I know what the data type should be. I got a requirements doc. We architected this thing out. I know that I'm only supposed to get ISBNs or something like this if I'm running a bookstore in this field. I know what that format should be. I know what the valid range is. I know what the data type is. If this is a zip code, I know it's not ever going to contain letters. I mean, everything about the input you're receiving is defined. You know what it is. So how secure are traditional web applications? Really, really insecure. I always like to tell this story. There's a major news organization that exists. They're the main news organization, which I guess is not fair and balanced because that's not their slogan. But they have a vulnerability in their one of their news story pages. And so every year on my mom's birthday, I send her a link. And it's a news story with a byline of Bob Woodward saying Mary Hoffman is the greatest mother in the world. And it goes through and proceeds to say, it's like, sources close to the investigation say that she makes a hell of a pancake. And I just proceed to send her this. She has no idea how I do it. She comes up to me, she's like, you didn't hack that news site, did you? I'm like, no. I just injected cross-site scripting, and it rewrote the page and made all this content about my mom really kicking ass. So Gartner, it's fun. I highly encourage people to go out and investigate their own web applications, because there's all sorts of fun things you can find out there. There are also a lot of dangerous things as well. And Gartner is saying that 70% of all attacks now are coming through the application layer. You really got to liken this to a house again. Layers 3 and layers 4, IDSs, firewalls, things like that, they're by no means perfect, but we kind of have solutions to this. It's reasonably difficult nowadays to, be able to telnet to back-end systems. So you think of this as a house, and your IDSs and your IPSs and your firewalls are like putting a really big Schlage lock on your front door. But you've got a web application running as well. And that web application talks to a back-end database. So if I want to extract data from that back-end database, I can try to pick your front lock, meaning get around your IDS, your firewall, things like that, or I can go through your website. And your website, if it's just a window and you didn't properly secure that, it doesn't have bars, it doesn't have anything, it doesn't matter how good of a lock you have on your front door, I'm just going to throw a cinder block through your window and take stuff that way. And so hackers take the path of least resistance, and web apps are the least resistance. You can't read full disclosure, any of the security mailing lists without seeing just a mess of cross-site scripting vulnerabilities, SQL injection vulnerabilities. So as we say, this is where things are going, this is where things are growing, and it just makes sense because hackers are lazy. So the theory here that we've kind of established is input validation should be easy in these traditional applications because we know everything ahead of time. We know data types, we know ranges. The reality is web developers are doing a very poor job of this. You can't go across the internet without stumbling upon ODBC error messages, SQL injection errors. You can't find, cross-site scripting is everywhere. It's funny, there's actually a search engine out there. It's not one of the big ones, but if you go looking for cross-site scripting vulnerabilities in their little search dialog, their search dialog box is cross-site scriptable. So if you type in script, alert, whatever, because you're looking for examples of cross-site scripting, you'll cross-site script the search engine trying to find other cross-site scripting vulnerabilities. So they're all over the place. Does anybody have any questions so far? Am I talking too fast? Is this good? All right. Starting to get that late morning kind of lull. All right, so AJAX applications really kind of extend the application to span both the client and the server. You'll see I've drawn this little green line farther down because what we do is, remember, JavaScript is now trapping that input and doing some type of process on it. AJAX is, or JavaScript is making an HTTP request to some web service now running on your server because it can make direct connections. So really what it's doing is it's making function calls in a way. It'll say things like, hey, give me the price for product ID 24. Or, hey, you know, I'm looking at, say, a mail portal, and there's a JavaScript, and every 30 seconds it fires off an AJAX request to find out if I have new mail. Or given the state, return all the valid cities there. Or, you know, hey, database, tell me what the last known address was. What we're really doing is sending to the server how to do what we want it to do. We'll tell it, say, if you're filling in a profile, you know, at a popular social networking site, you're updating, say, your age, your interests. As soon as you tab away from those checkboxes or something like that, instead of saying submit, some of these social sites will actually, as soon as you leave a text box, we use AJAX to go contact the server and say, let's update this attack, or let's update their address, or let's update this checkbox. So if I've got a form with 15 inputs, in a traditional web application, I'd fill in all these 15 inputs, click submit, and then it would go to the server. With AJAX, depending on how they write it, if I have 15 inputs, I could have 15 different web services that are all called on the back end where each one of those little pieces of data are inserted. So you start to see what I'm saying about the attack surface drastically increasing. So what does this mean for the attacker? Well, first of all, the attacker is now inside your application. If you're running things on the JavaScript logic layer, let's say they fill in this form, let's take all of the input values, create, say, a pipe or a comma-separated list, and then submit it to a web service. You're doing some type of packaging, munging on the back end, and then you're contacting a web service. Well, I now know the function names of that web service. I know the variables. I know the parameters. I know the data types of those parameters. I know valid ranges that your application accepts. Normally, I would need to either crawl your entire application and find all references to this, or I'd need to somehow extract actually the binary business logic from the website and then run, say, classic IDA Pro, do classic reverse engineering, trying to figure out what you're doing on the back end. But you're pushing some of this logic to me in the form of JavaScript now, in plain text. And also, your attack surface is increasing, like we said. We can now audit the application's API. All those web services you spawned, the attacker can directly contact them and start trying to screw with them. And really, this is exploiting the trust relationship between the client and the server. I cannot reiterate it enough. You cannot trust anything you receive if on the server side, because the attacker can just directly contact you and submit everything. So really, with an AJAX application, we have 3 types of input now. We have form input, which is what classic web development sites had. You've got get a form variable with text boxes, radio buttons, text areas, and I can submit this with a get or a post. Validation obviously isn't implemented enough already. I mean, 70% of attacks through the web application layer, and that's been happening for a while. That's not because of AJAX. That's because people aren't very good at securing traditional forms. We've got file formats. I let you upload an image as an avatar for a forum, or you're able to share zip files with your friends. That's file formats. We saw numerous exploits. Obviously, the WFM exploit this past winter. There have been a bunch of bugs in the JPEG and ping image handling libraries. There have been buffer overflows. So you even have to validate that the files you're receiving from the user are of the proper format and aren't going to do something nasty when you actually start processing them. And now, because of AJAX, we've got more and more exposed functions in web services for AJAX to phone home to. I mean, and you've got control logic functions, look this part up in the database. These rarely have validation, namely because application developers don't think of these as input. If we go back here, this is the way applications used to be. When the web server needed to talk to the database is just like, oh, the web server's talking to me. This has got to be good, because why would the web server lie to me? But when you're here and Ajax is making a request to the server and the server is just kind of passing it along to the database, if when you converted your application to be Ajax enabled, you've violated that assumption. Your database is still assuming everything it's get is going to be safe, it's going to be sweet, because why would anybody attack you? It's inside the application. But if your application straddles this internet cloud, I directly talk to them and I start screwing you up. So, I kid you not, I actually found this as a web service in the wild. It was a real application, one of these Web 2.0-y Ajax applications, and this is a function for the user to update their password. It basically takes in the username and the new password they want to use. It, interestingly enough, makes a SQL injectable string. So even if I didn't just simply want to reset everybody's password on your entire site, I could SQL inject you and dump the database out. Basically, it constructs it, sends an update statement, and the other thing is they're also cross-site scriptable, because I give you a new password, and what's actually being returned to the user is this text string, password updated to whatever you had, and that actually ends up being placed on the web page. So if I change my password to script alert or script port scanning piece of code, that's not going to execute. So this thing was vulnerable 3 different ways, and this was actually rather popular, and you guys would know it if I said the site, Ajax, or specifically an Atlas web app. So repudiation of requests, or as I like to say, I really didn't make that stock trade, trust me. So what is repudiation? This is something that has very specific meanings in cryptography. Specifically, you're looking at non-repudiation. In cryptography, if you and I have a conversation, after the fact, I don't want you to be able to say, nah, Billy, we never talked about that. I can prove to you that we did, in fact, talk about that. Well, with Ajax, you can't prove that anything happened. And here's why. HTTP requests from Ajax are identical to the server. These are 2 requests. The one on the left was made to Google Maps just to fetch the initial page. The second request was made by Ajax from Google Maps. You'll notice that it actually has the same cookie. The browser goes ahead, shoves all that stuff in for me. It's got the user agent, everything. From the web server's point of view, this is just an HTTP request. There's no magical header. There's nothing here that knows, okay, this was a request made by script on somebody's behalf, as opposed to this is a request made by someone actually clicking on a link. So this is very interesting. You can't prove you didn't make an HTTP request. In other words, JavaScript can now make requests for you for any type of resources. And because Ajax is so handy, yes? Yes, I'm sorry. That is a very good point. The refer, the reason that is different is that I actually typed in maps.google.com, and when you type it in, there is no refer because I wasn't coming from anywhere. Now, the refer lets you know that maps.google.com was the site I was on, but if I was on maps.google.com and I clicked a link to say, go to the About page, the HTTP request I would send would have a refer saying this request came from someone clicking on a link on maps.com. So the refer in and of itself isn't a way to tell whether Ajax made the request or a user makes that request. Like I said, the only reason that request on the left doesn't have a refer is because that was the first page I visited and I actually manually typed it in. So in other words, JavaScript can make a request for a resource. This request is in the background. It's hidden. You can't tell. This happens while you are using the computer because you're interacting with the website. The browser automatically shoves on cookies, other types of HTTP auth. It'll stick HTTP basic auth on there for you. JavaScript can then read the response that comes back, derive out knowledge, and then send additional requests. And the server thinks you did all of this. And there's no way you can prove that you didn't do this. Then that script did it on your behalf. So this obviously has huge implications for cross-site scripting, which I'm not going to go into. Well, how many people here know what cross-site scripting is? Please raise your hand. Okay, obviously, yes. The traditional things we saw was session hijacking, information leakage. You can do key logging. You can scrape the contents of the screen. Jeremiah was just showing how you can steal browser history, some other fun stuff. Well, now I can send malicious requests. Ajax amplifies what I can do with a cross-site scripting attack. Yes? No. And let me really hit this hard. Ajax has absolutely nothing to do with your web server. Let me repeat that. Ajax has nothing to do with your web server. Ajax is in essence, an extension to the JavaScript language. It's not technically in the spec, it's an object you initialize and use. It happens on the client. If I have billysbooks.com and I'm cross-site scriptable, and nowhere on my site do I use Ajax, someone can still inject script, which then uses Ajax to talk to me. There's no magical switch. You turn on the server and suddenly you have Ajax. Ajax is present in every single major browser. Any modern browser has the ability to send an Ajax request. It has nothing to do with what's on the server. And that's why it's so bad. We're going to talk about the Yahoo, the Yammer worm, and Yahoo's mail portal wasn't using Ajax at that point. It didn't have, in the screen you were accessing, there were no Ajax calls, but Ajax was still used by the cross-site scripting payload. I'm just going to go through that real quick. So cross-site scripting can now make malicious requests on the user's behalf using their credentials, because I'm using the cookie. There's no hard refresh. This drastically increases the damage that I can do. Consider screen scraping, where I'm trying to steal the data you're currently looking at. You're browsing along, I've cross-site scripted you, and while you're on the page that's got the cross-site scripting, I can read the contents of that page. Or I can pop open an iframe, keep you on that page, and still be reading the other sites that you're visiting, or the other pages inside that site you're visiting. But this is really passive. It's like a Venus flytrap. I happen to get there, and anything that comes along, I can just passively sniff up. But think about Ajax, right? If I inject cross-site scripting, it's now running in your browser, and I start making requests saying, hey, web server, I would love to see my user, I would love to see the user settings page so I can extract out the password. Or hey, I would love to go look at my inbox. Maybe I find a cross-site scripting vulnerability in one part of, say, a web portal, which is in the address box, or it's in the address book. And that's the only page it's vulnerable on. So traditionally, the only thing I could do before Ajax is just steal all your addresses. Because as soon as you leave that page, if I don't find out our cross-site scripting exploits, I can't steal anything else. But now I can actively hunt. You go and you look at your address book, Ajax runs, and then Ajax says, hey, web portal, give me my inbox. And then the inbox comes down, and then I start saying, hey, give me message 1, give me message 2, give me message 3. Meanwhile, the user still looking at their address book has no idea that these requests are happening in the background. I'm actively hunting and stealing data that normally I couldn't do through passive filtering or passive sniffing. So so obviously after Ajax, that went quick. So obviously, injecting and propagating cross-site scripting. Before Ajax, you'd do it by hand. You'd find a cross-site scripting vulnerability. Maybe I injected in some back-end database. I'd find it by hand. You've got reflected-based cross-site scripting and stored-based, which is when it goes in the database. You could kind of have cross-site scripting self-propagate itself by using the image object and DOM tricks. But like we said, JavaScript, short of Ajax, can't look at the responses. So I never actually saw anything in the wild. I did see some papers kind of early in like 2002 that were talking about trying to use JavaScript to use cross-site scripting that would self-propagate. But it never really left kind of academic theory. But after Ajax, my cross-site scripting payload can automatically or autonomously inject itself back into another page. I can keep injecting myself into other hosts. It's all seamless. There are no hard refreshes. And interestingly enough, when I get the response, because I can analyze it, I can send more requests. So Ajax can go through complex login sequences. This kind of sounds a lot like a virus, doesn't it? Well, that's because it is. I'll talk about this more in the web application worms and virus talks. And then I'm actually kind of moving away from this terminology. I use the phrase web virus because this type of malware is a lot like your traditional COM virus or an EXE virus. You'd run it on a computer, and all it could do is infect other programs on that host. You can't leave. Well, because Ajax can't contact other hosts, the only thing you can do is re-inject cross-site scripting into other parts of the site. The MySpace worm, the cross-site scripting exploit, basically Sammy found how to get script into his profile. You looked at his profile. Suddenly you made an Ajax request to MySpace saying, hey, I want to update my profile with this big block of JavaScript code. And then it would use Ajax to force the user to add Sammy to their friends list. How did this actually work? Well, this is interesting. What happened is when you view someone's profile on MySpace, you're using the host profile.myspace.com. And so I make a request for somebody's profile, and down comes their profile with the nasty JavaScript inside. Now, the interesting thing is all the functionality to be able to upgrade and change your profile and edit it aren't actually on profile.myspace.com. It's on www.myspace.com. And we know that Ajax isn't allowed to talk to that host, which is a little odd. I mean, if Ajax can't phone home and say, hey, here's what's going on, You know, you got to find some way to get to www.myspace.com. Well, interestingly enough, profile.myspace.com and www.myspace.com, while they don't have the same web root, you can read profiles on www.myspace.com. If you're looking at someone's profile and you simply replace profile.myspace with www.myspace and request the page, you'll get the same thing back. And so what this virus did is, once this thing came down, the very first thing it would do, JavaScript, is say, hey, whatever page I'm currently looking at, go look at that page on www.myspace.com. And so the request would go up, and these two pages are exactly identical. They just got fetched from different domains. The JavaScript would come down. It would now run. MySpace actually issues these little one-time hashes or one-time pads whenever you want to actually update your profile. And so what the Sammy worm would do would go ahead and, let's say, make a request to myspace.com saying, hey, I'd love to update my profile. MySpace.com pushes down a request that says, okay, are you sure you really want to do this? And embedded in that page was a little MD5 little hash thing. The Sammy worm used a regex to extract that hash and then made a request back to myspace.com saying, no, trust me, I want to update my profile. Here's that little hash you just gave me. So this is very interesting. You looked at one page and JavaScript made 3 requests here on your behalf. You didn't even realize these requests happened, and your profile just got injected. And in fact, I left them off. There's actually another 2 requests made to add Sammy to your friends list and then add Sammy as my hero to your heroes list. So it's an awesome hack. I, in fact, did not write it. Sammy did, but it was really kind of funny because a month before at TourCon out in San Diego, I was giving a presentation about using cross-site scripting in Ajax to do really nasty things. And then the very next month, it happened, and it was really kind of both very interesting and very scary to watch something you were talking about actually happen. It's a beautiful proof of concept that even though Ajax says you're only allowed to talk back to the host you came from, this is still a problem. It obeys the DOM security model, but I can now use Ajax to screw you on the site that has the cross-site scripting vulnerability in it. It also shows how Ajax and regexes can handle these complex login sequences. I was able to, say, I want to do this. You gave me a hash. I extracted out that hash. Short of, say, a CAPTCHA or 2-factor authentication, Ajax, JavaScript, and regexes can get through any sequence of login prompts. MySpace really lucked out because it could have been much worse. Well, how much worse? Well, let's go ask Yahoo because they just got nailed about a month ago. In June 2006, this infection took down the 3rd largest web mail provider. It was JavaScript with Ajax. The attack vector was there was JavaScript that got inserted into the message. Basically, you would look at this message. So, I'd go sign into Yahoo, open my inbox, go, oh, cool, it's a message from my friend Jake. I'd read the message. Immediately, JavaScript would execute, and it would say to Yahoo, hey, Yahoo, I'm Billy. Here's my cookie. Browser added this for me. Give me my address book. And then I would use regexes. I'd strip out all those addresses and say, hey, Yahoo, I would love to send an email to every single one of these people. And please, as the body of the email I'm sending specifically to the Yahoo users, I'm sorry, it only forwarded the message to Yahoo users because those were the only people who could then execute it when they looked at it. It would say, hey, the body of this message should be the nasty JavaScript, which propagates the virus. It then stole your address book and sent it to a third-party site. And humorously enough, it attempted to pop open this ad window, but there was actually a typo in their code where they used they fat-fingered it and put in the domain name a comma instead of a period, and so it didn't work, which was really kind of funny. Let's take a look at the source code, actually, just to run through this really quick. Ooh. My mouse went away. Oh. My name is Billy, and I know how to use a computer. All right, so interestingly enough, it used an onload event in an image. So this was the body of the email. Hey, show on this pretty picture, which is a real picture that's on Yahoo, and then when it's done, run this giant block of JavaScript. And it starts way down here, and they wrote a little function to kind of facilitate using Ajax. But all this says is basically right down here, control, and this thing right here is basically sending, hey, make a request asking Yahoo for my mailbox, and when you're done, go contact the function list contacts, which is right here, list contacts. So it then says, hey, if I got a response and it was a 200, go ahead and call the function getIDs, which has a regex to actually extract out all your email lists. And now all your email addresses in your address book are stored in ID list. It then says, hey, go make a request to get a crumb. This is very similar to Yahoo's or to MySpace's thing of saying, hey, I need to have a little token that's saying, are you sure you want to send an email to these folks? So it goes, it grabs that little token right here, get crumb, and then says, all right, I'm now going to compose my email message. There's a big nasty block of all the stuff you had to send to Yahoo. It says the blind carbon copy list should be the ID list. So all those address books or all those addresses I stole, send them, my body. Go ahead right here, make request, and when you're done sending that message, go ahead and call alert contacts. And then right down here, alert contacts, it said, hey, once everything's done, go ahead and do a window.navigation event to this site, av3.net, and right here at the end of it, you can see, send them the ID list. So this is how they stole your address book after propagating. So we went from the MySpace.com virus to the Humanor virus in 8 months. You went from proof of concept, Sammy screwing around and having a lot of fun, to someone writing a worm to deliberately harvest email addresses for the purposes of selling them to spammers. Yahoo, first of all, should be ashamed. The onload event is one of the most trivial and obvious ways to execute script in HTML. Now, in their defense, there are thousands of ways to execute script inside an HTML page. There are thousands of tag and attribute combinations. There's something you can say, body, on air. You could say, when they click on this link, when they simply mouse over a piece of text, actually one that's really nice is saying image, the source is equal to just a dot, which that image doesn't exist, and then say on air, run this big block of JavaScript code. There are lots of ways to execute script in HTML. It's very hard. Wikipedia actually has a really good model about how you handle and accept markup. What they do is they say, hey, you want to update, you want to put something bold, we're going to use these little square brackets instead of actually accepting HTML because it's way too hard to try to determine what good HTML is and what bad HTML in JavaScript is. Yes? There was actually a vulnerability that came out about a week ago for PHP-BB. Or maybe it was vBulletin, I forget. But they have something where a user can insert a URL into their post by doing bracket URL equals the web address and then end bracket. Well, what you could do is you could enter bracket URL equals JavaScript colon and then JavaScript. It's what's known as a JavaScript URI. And when that URL is activated by the user clicking on it, they then execute JavaScript. So even then, when they had some type of meta HTML language to try to not actually have tags the browser could understand, you still could execute script. So just what are some of these design issues that we're kind of all talking about? The fact that requests can be made with the XML HTTP requests that are identical to the original request is a problem. The server cannot tell the difference. You cannot repudiate traffic that was created by AJAX. You cannot prove that you didn't do that. Consider this in a stock trading site. Think about MySpace.com. You view one page in we said 4 minimum, but then he went ahead and updated your profile, or updated your heroes list and added you to your friend list. Looking at one page caused 4 to 6 requests to be made without your knowledge, and from the server's point of view, nothing bad happened. That's what's really funny about this Yahoo thing, right? From Yahoo's point of view, here's what happened. I checked my mail. I opened a message. About a second and a half later, I made a request that said, I'd like my address book. About a second later, I made a request to Yahoo saying, I'd like to compose a mail message. About a second after that, I said, please send this mail message. From Yahoo's point of view, nothing is suspicious, other than maybe the timings, but with JavaScript, I can say, hey, wait a couple of seconds before you do this next thing. That's what's so scary about this, is the server can't tell that anything bad is happening. We're exploiting the trust between the client and the server. So I really want to push, I really want to see, the browser manufacturers who are implementing the different ActiveX objects and different things to actually instantiate the XML HTTP request. When you make an XML HTTP request, the browser should stick an HTTP header that simply says request made by : user event or a JavaScript event. The server needs to be able to know where these things came from because it doesn't right now. Yes? But Certainly, but you're directly attacking. That's when you're directly attacking the web application. I'm just saying from a propagation point of view, if I had let's say MySpace or Yahoo, because that's the other thing. You asked the question earlier about what about the application being AJAX enabled? The Yahoo Mail client wasn't AJAX enabled, but AJAX was used to steal addresses. If Yahoo had something in their, in their little thing, the page to say, get me my address book. If they had a little thing saying, hey, if the HTTP header doesn't say, or if the HTTP header says this was made by script and not a user event, ignore it. Yeah, you could directly contact it with Perl, but that's not self-propagating, because that's where the JavaScript has to propagate itself. And then what that means, though, is you could write a propagating worm in Perl, which I'm going to talk about this afternoon, but this is trying to defeat cross-site scripting, propagation, and AJAX. Does that answer your question? Okay, cool. Yes? Certainly, but please show me an organization that's implemented client-side cert successfully besides really, really scary government organizations. I mean, client-side certs, they're really good. Client-side certs would be great. I have never seen anyone do client-side certs properly. I really haven't. And a lot of, I don't know. First, well, here's another thing, right? Do you have a client-side cert for MySpace? Do you have a client-side cert for Amazon? That's the beautiful thing about SSL, right? When I connect to SSL, I've got a pretty good idea because Amazon's got a server-side cert that I am, in fact, talking to Amazon. Amazon has no idea who I'm talking to. And frankly, Amazon doesn't want to know. Amazon doesn't want to have to manage client-side certs for millions and millions of users. It's not practical. In a closed environment like the government, when you have a limited user pool, that's great. But if I was running an e-commerce business and I said, look, to talk to me, or a web mail, say, to talk to me, you need a client-side cert, nobody would use me. Because the whole point of having web applications is I can use them from everywhere. If I'm on the road, I'm at an internet cafe, I want to check my mail, I don't want to have to somehow, cart my private cert around on a PGP or a fob. I mean, it's a good idea, but it won't work in a lot of these types of applications. And even when it does work, people don't really do it right. Is that good? Was there another question I saw over here? Yes? We're going to get to that. But I mean, remember, everything I'm talking about here totally transcends frameworks. This is simply JavaScript making HTTP requests on your behalf. There's nothing, I mean, this doesn't even deal with frameworks because when I'm injecting a cross-site scripting attack, I'm probably not, injecting a framework along with my attack. It's custom. So this really kind of transcends different types of frameworks. But when we get to bridging, that's where you've got the fun implementations and frameworks. Yes? Oh, I'm sorry. Actually, that's a very good point. The beautiful thing about the browser, right, is the browser does so much for you. It goes, oh, you're making a request to Amazon? I've already got a cookie for Amazon. Let me slap that in. Or, oh, you're making a request to your browser, or your little Linksys firewall, 192.168.1.1. You've already cached those credentials with me. I'm going to go ahead and slap those credentials in for you. Which is why, actually, Jeremiah this morning, he was able to use an image object to send credentials to the browser. Because the browser goes, oh, you're going to this host? Hold on, let me check. Yeah, let me tack this stuff on there for you. So it's nasty. Ooh, I'm going back. So cross-site scripting is already dangerous, right? I mean, Spy Dynamics and White Hat Security actually both released, White Hat Security today, Spy Dynamics last week, released how to port scan in JavaScript. And it was really funny because Jeremiah and I were talking last night at the WASC meeting in the Shadow Bar, and it's kind of like, how did you do fingerprinting? And he's like, I used cascading style sheets. And I'm like, wow, we used image objects. So Jeremiah's presentation in the conference CD has his proof of concept. If you go to spydynamics.com right now and go to our Spy Labs, our expert articles, we wrote a white paper about this, and we've got a nice little piece of a proof of concept code where you can give it a range of IP addresses, and it'll just start scanning and popping up. We'll actually fingerprint the web server. We'll go, oh, here's IIS, here's Apache, and it just runs along. Actually, the way we did is we used image objects, and we say, hey, here's an image object, and if an error event fires, that's how I could find out whether there was a box there or not. And I would then use an iframe and an onload event to determine that it was in fact HTTP that was coming back to me and not some type of server banner. And finally, we would use image objects to request known images and then check their dimensions to try to fingerprint the device. So None of this that I just talked about is using Ajax, and it's already really, really bad. Ajax now allows JavaScript to make requests on your behalf using your credentials, and the server can't tell the difference. This is catastrophic. Yes? No, that's the interesting thing. Well, I'm sorry, let me take that back. That's why I was talking about using cross-site scripting propagation without Ajax. It was kind of talked about in the early 2000s. I never saw it ever in the wild. People kind of academically talked about it. And the problem is all these little things like image on air, frame on load, from JavaScript, I can never actually see the content that comes back. I don't get to see status codes. I don't get to see HTTP headers. These are kind of using side channels, and it's a dirty hack to try to do port scanning. But remember, Ajax, you couldn't port scan with Ajax. But, for example, consider the MySpace thing, right? Like, I made a request, it came back saying, are you sure? And included in the request was a little hash. And I had to extract that hash and then make a request to the yes, I am really, really sure page. And if I hadn't extracted that hash and submitted it to the second page, it wouldn't have gone through. So you really do, good God, you really do, for these propagation methods, need access to the response. So Ajax bridging. You were talking about Ajax frameworks. So let's talk about what an Ajax bridge is, because this is just fun. And I've got about 30 minutes left, I think. All right. You guys having fun? I'm not getting too many questions? All right, good. Yeah, thank you. All right, this is destroying the internet. This is fun stuff. Okay, so Ajax bridgings is a complete hack. It's to overcome this limitation in the Ajax implementation. Basically, it provides a bridge between client-side script so it can access web services, content, and stuff on third parties. It's literally a web service to another web service. How does it work? Well, like we said, Ajax can only connect back to the host it came from. To allow scripts to go talk to some third-party site, for example, I'm billysbooks.com. I want my web services or my Ajax that I push down to the client to be able to talk to Amazon. Can't talk directly. So on billysbooks.com, I open a web service, and then everything that comes into that web service, I basically, analyze slightly, and then forward it to Amazon. Amazon responds to the web service, and then the web service responds to the JavaScript. Yes, Andrew. Yes, Adobe has some stuff, the Flash bridges. It's the same concept. Whether you're using a web service or whether, exactly how you're implementing the bridge kind of varies from framework to framework, but it's just literally a proxy. This JavaScript needs to talk to some third party. We need to provide a proxy so it can do that because there's a design limitation. Actually, yes, that's the beautiful thing. Applets have the exact same restrictions that Ajax has. If you download an applet, a Java applet to your machine, it can make socket requests. It's only allowed to make socket requests back to the server it came from. Specifically, I don't know if it has the port limitation. I think it's only the host name. Interestingly enough, signed Java applets can make HTTP requests anywhere. So the same way where people are like, yes, yes, to every message that pops up, I could push something down that says, this is a signed JavaScript applet. Do you want to run it? Yes. Okay, great. I'm port scanning you now. And more importantly, I'm port scanning you and I can see the responses because I can actually analyze and open sockets anywhere. There's actually a beautiful applet called MindTerm, I think. It's, if you type MindTerm or just simply Java applet SSH client into Google, you'll find it. It's a great way if you're at a browser and you need an SSH client, you just pop this up and it says, would you like to use this signed applet? And you're like, sure, because I'm right here and who cares about this kiosk? And you now can make SSH connections anywhere. In fact, is there anyone here from the federal government or the Library of Congress by chance? I really don't want to get carted away. But a couple years ago, I was up in DC at the Library of Congress and my VP of engineering is there going, oh my God. There was I wanted to check my mail, and MindTerm actually has built into it a secure copy, so you can pull down files. And so in the Library of Congress, we used MindTerm to go connect to people, and we could use secure copy, even though the machine was locked down, you couldn't copy stuff. We pulled down Scorched Earth and started playing Scorched Earth in the middle of the Library of Congress. but we didn't realize that they still had the speaker plugged in, the internal speaker. So you send that first nuke flying across the screen, it goes, woo, boom. The librarians kindly asked us to leave. So, all right. I just see Jaime there going, oh, God. I'm going to get a talking to afterwards. I hope you all enjoyed the story. I'll enjoy my imprisonment. So yes, you are correct. There is, applets can do this too if they're signed. And like I said, many frameworks support bridges. You can do custom implementations like CGI gateways, you know, ASP, PHP. All the popular frameworks support AJAX bridging. So data over the bridge. Well, what third-party services can this bridge talk to on behalf of the web service? Well, I can go contact a web service running on any host and talk SOAP to it, REST, maybe some type of custom XML protocol. I could just go connect to some arbitrary resource. I could have a web service on billiesbooks.com which pulls up arbitrary things from Flickr, or goes and pulls the very first image off you know, Google Images and pulls that back down. For, you know, I type in Stephen King and to billiesbooks.com. Billiesbooks.com goes, hey, Google Images, give me the first JPEG for, you know, Stephen King, pop that back. So arbitrary web resources also, we could grab SSH feeds, we could grab raw content, HTML, Flash, you know, any type of resource. What does this bridge return? JSON. JSON is just a way of serializing complicated objects in JavaScript. And the scary thing is basically what comes back to the browser gets dumped to the eval statement of JavaScript. Who here knows what the eval statement in JavaScript is? The eval statement basically says, look, I'm going to give you a string. It's got some code in it. Please execute it. That should scare the pants off anybody here. Here's some code. Please execute it. If I can man in the middle you, if I can even get a slight little input into your session, I can make your browser execute arbitrary code. And we just saw that I can port scan with arbitrary JavaScript. So that's a really interesting setup. You can grab XML, and the bridge could also actually return to the JavaScript and the AJAX running on the client. You know, here's a raw Flash object, which I then add to the DOM, or here's a raw, you know, XML, which I can then, you know, parse. Maybe it's a data island. It's basically it's just a sewer pipe. It's give me, I can ask for anything, and the bridge can go get anything on my behalf, and then give anything back to me. It's incredibly versatile. And that's why it's a problem, because we're exploiting the trust of mashups. Everybody loves mashups. My God, there's $1,500 conferences about the joys of mashups. Now, don't get me wrong, I love them. Mashups are basically sites aggregating third parties. There's a site, Housing Maps. Everyone heard of housingmaps.org? It's a site that takes Google Maps and lets you take Craigslist apartment listings. So it's using the API of Craigslist and the RSS feeds from Craigslist, and it's accessing the Google Map API and will map apartments on top of Google Maps. Everybody here heard of chicagocrime.org? This is really great. It takes Google Maps and the public crime statistics of Chicago, and instead of that nice little thing that says, you know, oh, your destination is here, it's like, yes, there was information theft here and armed robbery here. What they really need is yet a third aggregate site which takes the crime data from Chicago and apartment listings, overlays the two, so you can say, like, you know, find me things where, you know, misdemeanor, you know, vandalism or whatever hasn't occurred in the last 6 months. So, and if you do that, please, you know, 3% royalties, I think, is fair. So any web service is fair game here. Here's the beautiful thing, though. Any commercial use normally requires a formal agreement. Anybody right now can go sign up to access Yahoo API or the Google Maps API. If they're using it for a commercial product, you and, say, Google have to enter into some type of formal agreement. Now, this is beautiful. These formal agreements carry some type of trust. I mean, because if I'm Housing Maps and here's Google, why would Housing Maps ever try to hurt me? I mean, you're going to access me. You know, the aggregator agrees it will and will not do certain things. There's stuff about how many unique queries I'll make, what's the throughput, what's the bandwidth. The bridge provides a hole to circumvent most of these rules, because what's happening now is, you know, maybe Housing Maps and Google have made an agreement that they'll only do so many transactions a day, and they won't try to attack each other, and they'll, you know, enrich shareholder value. I always love that phrase. But with a bridge, you know, if let's say Housing Maps had a bridge, they actually don't, but if they did, they are now proxying requests to me. And unless they validate the input going to that bridge, unless they try to do stuff to lock that bridge down, I can get around all those things that housing map said of, oh, we'll never SQL inject you or anything like that. Well, I never made that agreement. Of course I'm going to try to SQL inject you. And bridges really allow malicious users to exploit this trust. Whoa. So there are security issues with bridges, obviously. It's an open proxy, but it only goes one place. It's going to go to, at billiesbooks.com, it's an open proxy to amazon.com, and it only goes there. There are no built-in security mechanisms into any of the bridges. There's no throttling, the number of times the bridge will clamp after so many people ask it, the same user asks it a bunch of requests. There's no authentication, there's no authorization, and there's no obfuscation of what's actually being sent and what's coming back. It relies on other components for the security. It requires SSL. You've already done a web form. I've already issued a session cookie. I mean, it doesn't do any of this stuff itself. It relies on other mechanisms. Well, good Lord, we've already seen those other mechanisms don't work very well now, do they? Because traditional web apps, we've got 70% of attacks coming through the application layer. So this is yet another input that attackers can try to attack you through. Like we said, we've seen how well this works. There are so many attack vectors against an AJAX bridge. I'm only going to talk about 2 of them. Dumping a database through a bridge. So let's say I wanted to dump out Amazon's bookstore. I wanted to dump out their author's database. I could go download and sign up for a free key to access their API, and it would probably be extremely limited. I could probably only ask it 250, maybe 500 questions a day. They probably throttle the bandwidth, so it comes back kind of slow. There's no quality assurance guarantees. But let's say I had a book lover site, Billy's Books. Well, chances are Billy's Books and Amazon, when they entered a more formal agreement, Billy's Books has hundreds of users, hopefully thousands. That would be great. If it's got all those users, obviously billiesbooks.com needs to make more unique queries to Amazon.com's web services than I need to make. So these kind of things that are allowed, more simultaneous connections, higher bandwidth limits, more unique queries. So what this means is that if I wanted to extract out all the authors of Amazon.com, if I signed up myself, I could get maybe 500 a day. I go through billiesbooks.com and say, hey, Billy's Books, I want knowledge about this about this author. And Billy's Books goes and talks to Amazon on my behalf. I could dump potentially thousands of authors in a day. So it actually makes sense for an attacker to use an AJAX bridge to dump a database than trying to do it directly. Now, this is the funny thing. Any performance enhancements that billiesbooks.com does only ends up helping me. Let's say the aggregate site, Billy's Books, has some type of cache. Well, if it's caching these queries, every time I ask it an author, if that author's in the cache, that's one less query it's got to go make to Amazon. And it comes back to me twice as quickly. So any performance increases only means I get more authors and I get them faster. Did you have a question? Yes. Oh, I'm sorry. Certainly. I assure you, I haven't had a bunch of coffee today. 10? Excellent. Okay. I'll tell you what, I apologize I talk so fast. We're actually almost done with bridges. Could I speak with you afterwards because I still have one more section? Thank you. The other thing you can do with a bridge is I can attack a third-party site through the bridge. So, I have billiesbooks.com with a web service. It's going to relay all my attacks to Amazon. So instead of attacking Amazon directly, I send the request to Billy's Bridge, and Billy's Bookstore sends the attack to Amazon. At the most basic thing, let's say Google, or well, in this case, Amazon notices that Billy's Books is trying to SQL inject them. At the very least, Google goes and contacts Billy's Books, or Amazon contacts Billy's Books and says, dude, what are you doing? And in which case, billiesbooks.com goes and looks at its logs and goes, wow, all right, let's go track down this guy. But that's another layer I can hide behind. At the very most basic advantage for a hacker with an AJAX bridge is that it's another layer to hide behind. Let's say that there's an auto-shunning or an IDS between billiesbooks.com and amazons.com. And let's say this IDS notices a SQL injection attack. Well, the IDS is probably, or the IPS is probably going to say, I'm going to clamp this IP address for 3 minutes and not let them make any queries because they're trying to attack me. I tried to SQL inject Amazon.com, and instead I've done a denial of service attack against all of billiesbooks.com because it can no longer talk to Amazon's books. So, if I'm just trying to cause mischief, again, the attacker wins here. It's an unintended consequence, but I still managed to cause a lot of damage by going through a bridge as opposed to attacking directly. Now, this is the interesting thing. What happens if Amazon doesn't even notice the attack at all. And this might make sense, because if I'm a large site like Amazon.com, excuse me, Amazon.com, and I have a lot of affiliates, you know, BillysBooks.com, you know, FrenchBooks.com, you know, CanadianBooks.com, and all of those people are making bunches of requests a day, chances are that I'm going to just go, look, I don't have time to do the same input validation against these affiliates that I do against just regular people contacting me. Besides, we already have a formal agreement not to attack each other, so I'm going to, just for performance reasons, subject those requests to less analysis. So what this means is it's possible that an attack could only work if I go through a SQL bridge, or an AJAX bridge, because the end site is performing less validation on things coming from affiliates than regular people. So there are some layers of indirection here. I'm actually not going to go into this, but basically a bridge can kind of, if I have a web service that's called, like, you know, search for, you know, Billy's books or Billy's golf books, and I just accept an author name, maybe the variable names and the data types that I use on my web service are different than the one Amazon does. So if I just directly forward the data, it won't work. There might be a little translation layer where they say, oh, this is the author name. That's actually supposed to be writer's name when I contact Amazon. So there's a little bit of translation that goes on there. It's possible that error messages, when I SQL inject Amazon, that come back, Billy's books will filter them before it goes back to the client. Well, luckily, we have a whole study and a lot of history on how to attack machines when you're not getting error messages back. Please reference blind SQL injection. I unfortunately am running a little behind. I don't have time to go into it here. But we already know how to attack sites when error messages are being suppressed. So hype surrounding AJAX. Web 2.0 is almost like another bubble. I mean, I'm not saying whether this is right or wrong, so, you know, don't hold me to this, but there's a lot of money in the air. MySpace got purchased by News Corp, Rightly got purchased by Google, Delicious, Facebook. I gotta imagine the gall of these guys. These guys are college students, they created this site, and they turned down $700 million for it and said something like, nah, we were thinking more like $1.2 billion. So there's a lot of money in the air, and people are thinking, wow, I gotta get into web apps. There's a lot of buzzwords. This hype is really having a lot of effects. First of all, people are moving to client-side web applications for all the wrong reasons. They want to either appear trendy, they want to fight off perceived competitors, and just quite frankly, having a sexy new front end on your website is more pleasing to customers than you spending your time fixing your bug fixes. Your customers want it, and frankly, your programmers would probably rather be doing that than, you know, fixing security bugs. So, and sometimes just because they can, they'll do it. So what is this doing? It's driving inexperienced web developers into the space. There are these giant demands now of 5? All right, fantastic. There are these giant demands that are saying, look, we need web developers fast because we got to have this AJAX thing. I don't really understand it. Nobody really knows what Web 2.0 is, but I need to have it today. And so there's a lot of developers who don't necessarily know the nuances of web programming. They're novices to it. They may be experienced developers, but they're not experienced web developers. And as we've seen with validation and some of these other architecture issues, you really need to understand the nuances of web applications to be able to develop them securely. This really encourages cut and paste application development. I go to a blog, I want to implement something, I type it into Google, I find some forum site for software coders, finally some smart guy gives the answer, I copy the code, paste it into my application. I have no way of knowing whether that code was actually done by an expert or not. And indeed, because there are so many people coming into the field, the percentage of the total population of web programmers who are very, very knowledgeable about security is decreasing because there are more people coming into this field. Coincidentally, book developers and authors are saying, well, you know what? I need to write a book about AJAX or a book about web programming targeted at novices because that's the growing part of this market. And so more and more of these books have simplified examples. They're not necessarily teaching the best practices. And someone with a lot of experience will say, I'm already a programmer. I'm going to read this novice book about web programming, and now I'm going to go make a site. And that's kind of causing problems. You know, I don't want to single anyone out. There's, you know, one company that uses Teach Yourself. I just happen to use that because it's the first one I saw. You cannot learn anything in 24 hours. You can't. The only thing you can learn in unless it goes in short-term memory and then you lose it. The only thing you can learn in 24 hours is how to make a very, very dangerous web app that is not secure in any way, shape, or form and exposes your users to risk. And people who write these books should be ashamed of themselves. No, I mean, I'm not trying to be funny. Seriously, this is really causing a problem because someone will read the book and say, I've had 15 years of programming experience. I understand this stuff. Okay, great. I got to the end of the book. There's nothing more to go. I'm going to go on. And because it's a shrinking population of people who are knowledgeable in this, technical FAQs, things like that, they're not including this more advanced knowledge. And you end up having moderately more intelligent novices helping out novices and not giving very good advice. I'm not trying to criticize anyone. I'm just saying this is irresponsible, and we need to, novice books aren't bad, but we need to have books that are also aimed at, all right, here's how you secure it. I often laugh because the O'Reilly PHP, Securing PHP book is 107 pages, but those are the best 107 pages you can ever read about creating a web app. Even if it's not PHP, it teaches you everything about stopping SQL injection, session hijacking, everything. Everybody should read that book. But that content, that 100 pages, is not ever included in these 1,200-page tomes about web security. I'm almost done, aren't I? Is that 3? 2, 1, okay. Anyway, the rush to Web 2.0i's applications, you really need to think things through. The end result of this, there are already way too many web application vulnerabilities. We're already seeing bad design choices. We need reasonably educated people. We need to improve our technical resources. So, design checklist. First thing you've got to ask yourself is, should I even have an AJAX-enabled website? I've seen applications that have no business being web apps, like mortgage processing applications, let alone applications that have more attack surface. Is it really necessary? What's gained by having a responsive website? When you're retrofitting an old application, document all of the inputs. Ensure input validation exists for everything that's already there. And then every new input you create, immediately apply input validation. When you're designing an AJAX application, you need to minimize the amount of logic you're putting on the client side. Intercept those clicks, send responsive applications, but don't do business logic on the client side. And finally, use clear standards. Don't use little hacks. Don't use little custom scripts that you find. Really make sure you understand what's going on. Just real quick conclusion, AJAX is a powerful suite of technologies, and I'm not trying to tell you not to use it. What I'm trying to do is say that AJAX can improve the user experience when it's used appropriately. They live on both the client and the server. It increases the attack surface. It exposes internal function names, control layers. If you secure your application, this shouldn't be a problem. But we already see, history's telling us we haven't figured out how to do that yet, and now we're just increasing the attack surface. AJAX bridges, interesting, but inherently they don't have any security issues. So if you're using AJAX bridges, you need to ensure throttling, authentication, using other mechanisms. And finally, the hype around AJAX may be deserved, and God knows I love my Google Maps, but seriously, it's hurting the industry. We need to have responsible education, not frantic education trying to capitalize. Just real quick, Spy Dynamics released a white paper about AJAX security. If you simply go to spydynamics.com, Spy Labs, and white papers, you'll see it. And I am done. Thank you. My name is Billy Hoffman. You've been great.